Welcome everybody. This is Dr. Mohammad Islam Mia, Assistant Professor of Petroleum and Mining Engineering Department, Chittagong University of Engineering Technology. Now I will present on AI-based water saturation models and variable selection for gas resource assessment using dynamic log data. So, the sustainable energy resource assessment is crucial for energy security to meet sustainable development goals. You know that affordable and clean energy is one of the main components for this SDG. Another thing, AI is one of the global main technological advancement for the 4IR, including IoT for this global perspective. AI can be helped to achieve breakthrough in predictive model accuracy, safety, and accurate assessment of hydrocarbon for energy security. Nowadays, natural gas is one of the top main energy resources, not only Bangladesh, but also in the globally. So still we are focusing on this major fossil fuel, coal, oil, and gas. So if we go for background of the study, I have one project on band-based. So according to our national perspective, when I went through literature review, we know and we also found that Bangabandhu Sheikh Mujibur Rahman gave the top priority to the sustainable development of the energy sector, as well as also 5 major gas fields on 9 August 1975. This was one of the top major energy security for the Bangladesh. But still now, we did not discover huge amount of gas located in the underground as well as major gas field. No major achievement. But it is important also to assess the accurate gas reserve or gas resource in the subsurface. Last 2009 and 10, Petrobangla with help international company, they resource assessment, but still after 12 years, they did not do any up-to-date resource assessment because natural resource assessment depend on the subsurface geological reservoir production data, reservoir data, because it's depend on the exploratory well, development well. So we need to be up to date with proper utilization of the new technology like artificial intelligence. So that's the background of my research for this project. Please. Next slide. So on this research project, main objective is to investigate the performance of water saturation models, then compare the predictive models of AI techniques through statistical analysis. Then to perform comprehensive parametric sensitivity analysis and find the most contributing variable for obtaining fluid saturation. So now how we'll do this? So before applying AI, we need to be proper and accurate data acquisition. Is it reliable or not? Before that, we are generally found reservoir data, especially logging data and production data. If we look for this logging data as well as core data, we found like this core analysis data, lithology log. I think if you are petroleum engineer or any related like geological knowledge, I think you know very well. So we can found this resistivity log data, then porosity and some other parameter. All these parameter, then we can come up some empirical correlation, like it's depend more complex, that is the fluid saturation. In the pore space, we generally found water or either any fluid. Like if it is oil, then water and oil equal to 1. If we pour gas, single phase reservoir, then gas plus water equal to 1. That means if we estimate properly water saturation, then we can see how much percentage are found on this pore space, on the bulk volume, on the rock. So we need to be focusing on SW. If we say that, okay, SW is only for 20%, that means 80% gas saturation. If we say that, it need to be reliable and predictive with proper justification. Then finally, we need to be gas initially in place. That means subsurface location, how much gas we can found. So it's depend on other parameter. So it is one of the most important parameter is fluid saturation. That means water or gas saturation. So it is like figure 1. Then if we go for AI technology, at first we need to be collect the data. For this field, log data. Then we need to be data stratification. We generally for AI technology, training, testing, validation. Sometimes we use only for 2 types of data stratification. One is training, another is testing or validation. It depends on how you want to use for this data stratification. Then construct the AI-based model. Either it is supervised machine learning model or unsupervised. We generally use for predictive model supervised machine learning. So here is the like artificial neural network, least square support vector machine, or any others like random forest, recurrent neural network, convolution neural network. Lots of models are available. Then we need to be check the AI model performance. It is how much accuracy we need to be like check. Then if our desired performance is acceptable, then we go for further step, like they use the network to predict target variable, then evaluate the model using statistical parameters, then choose the optimized model for further evaluation, like this feature ranking or variable ranking or something like this. If the predictive model performance is not acceptable, then we have to go back again, data stratification, then tuning the parameter and other things. Then we can back again for this following this flowchart figure 2. Then after getting the optimized model, then we can go for like this different techniques, like single variable technique, single input variable elimination process, or 2 variable input. Like it's depend on the how do they adapt the model optimization or feature ranking in the study. So in this study, I am just focusing on this. There is 4 input variable. One is elimination. Like we are living here, we are 5. So we want to eliminate one by one. How much impact on this model to obtain our desired output? So then estimate the model. Then we will statistical analysis, how they predict the correlation coefficient and statistical error, like average absolute percentage error, maximum average percentage error, then root mean square error. So according to this flowchart figure 3, then we finally say that which parameter is high dependency or low dependency. If we rank this properly, like okay, there is 5 input variable. If we find these 3 major is for most contributing, then we can go for only 3 variable to obtain this water saturation. You know, in subsurface, if we use lots of data logging tool, we need time as well as financial matter. We are looking always less financial issues, more profitable or more productive. Then finally, we can rank according to their performance, like input variable number 1 to 3 or something like that. So then we can go then further slide. So in this study, we use this MPI, that means model performance indicator, determination of coefficient, CC or R square, whatever we say, then AAP, then root mean square error, then MAPI, then according to this absence input variable, that means in the high impact on the model system, that means predictive model has high error and low CC or R square value. It's just reverse process of this normal trend. So in this study, we collected this data from Bakrabad gas field, well number 13. This is unofficial. We are saying that because it is data restricted, but due to for this research purpose, we collected this data. So after getting this data, we data acquisition, then we check this normalization. It is required normalization or not, checking the heterogeneity. Then at a glance outcomes from this research, we found that we developed there is 5 model. Model number 1, 4 input. What is GR? Gamma ray. You know that is heavy mineral. We know the gamma ray activities. So this radioactivities mineral gamma ray. Then rho B, formation bulk density. Then neutron porosity. Then photoelectric absorption coefficient. Then another one is resistivity, that is true resistivity. In generally, with subsurface, we categorize these three: flat zone, uninvolved zone, and virgin zone. So in this one, this virgin zone. Then model number 2, absence of rho B. Model 3, like this, Newton porosity. Then photoelectric efficient coefficient, absorption coefficient. Then another model number 5, in absence of gamma ray. So according to this data analysis, as well as this AI application to obtain fluid saturation, here we found that model number 1, in absence of RT, it seems like that low correlation coefficient as well as high model error. That means comparing with model number 5, in absence of this parameter, it gives our less predictive or less performance predictive model. That means this variable is most important to obtain water saturation. And also practically, geological information also, it is validated that we generally hydrocarbon saturation or something like that, we generally first focusing resistivity, it is high or low. So it is physical concept of it also validated that it is true resistivity using this AI. This is the most important parameter. Then secondly, rho B, bulk density of the formation. Then consequently, it close to this photoelectric absorption coefficient as well as Newton porosity. So according to these findings, we can say that RT and rho B, that means true resistivity and formation or bulk density, is the two variables are the primary input variables or input log data to obtain fluid saturation for the gas saturation assessment. Then concluding remarks, if we say few words at a glance, artificial neural network and least square support vector models agreed that rho B and RT are found to be the most important parameter to obtain fluid saturation. Then it also good agreement is noticed between the prediction and field data, implying the AI-based prediction and accuracy precision of the proposed predictive tools, that means AI tools. The parametric sensitivity analysis is achieved with the geological log data with acceptable accuracy to develop an accurate model for water saturation. Finally, considering the importance of natural hydrocarbon resource assessment, the expected fluid saturation or water saturation profile will support obtaining accurate resource estimation using AI technique. Additionally, we can say that we can also apply other techniques of AI like supervised machine learning, random forest, support vector machine, decision tree, fuzzy logic, or any other predictive models we apply to obtain this fluid saturation, like this 4I, one of these components for the gas resource assessment, as well as oil and gas industry, including other engineering field. Finally, I would like to express my deepest gratitude to session chairs, co-chairs, researcher, audience, including Bangladesh Bureau of Educational Information and Statistics, ban-based Minister of Education, Bangladesh, and Department of Petroleum Mining Engineering, CEUET, and also this organizing this Science and Technology Affairs Subcommittee of Bangladesh Awami League. Thank you for all.
Okay, I am not an expert of your field, but what I want to say about one query, as a gas plus water, you mentioned one. What is this? Is it truly accurate? Gas plus water equals one. That means if we have
Yes, exactly.
gas plus water equals one. It is a better case.
Yes. Yes, sir. It's yes. So yeah, I'm saying, so if we go for single phase, we are saying that oil or gas. Okay. Now that means oil, gas. If we go for two phase reservoir, oil, gas, and water. sometimes we say multi-phase, that means two-phase. Okay. So in terms of gas resource assessment, it's depend on how much fluid are there, and also porosity, and also deep reservoir thickness, and also reservoir area. So it is lots of uncertainty and need more information. If we go for the big data utilization, this data surface data, then we can go for step by step. So like this one portion here is fluid saturation or water saturation.
One just point from my side, actually, your data. So this data is almost pre-processed data, or these are the raw data you are using for the experiment? Because you are mentioning many outliers or many issues.
Thank you so much. So this all data is coming from subsurface raw data. After this raw data, we are checked. Some logs we cannot use because due to the borehole cavings or washout, we have to first check is data is reliable for further analysis or not. We need to be check data quality. After that, sometimes we need to be normalization. If it is highly nonlinear, so we are trying to 0 to 1 or -1 to 1. So in this study, we did not use this any normalization because our data is not so much highly nonlinear. Thank you. Thank you.